This presentation is a compilation of chapters 25, 26, and 27. 25 is Introduction to Personal Computers, 26 is Microcontrollers, and 27 is Careers in Electronics. Chapter 25, Introduction to the Personal Computer, or PC. The objectives of this chapter are to define the field replacement units, explain the function of BIOS, describe the power on self-test or post, describe how data is stored as magnetic data or magnetic media, identify various types of computer ports, and finally identify various factors that affect processor speed. Some of the keywords encountered in this chapter are application, basic input-output system or BIOS, central processing unit or CPU, chipset, digital video disk, direct memory access, DMA, double data rate or DRAM, DDR, DRAM, initial inline memory module or DIMM or DIMM, dynamic RAM, DRAM, field replacement units, FRU, file allocation table, FAT or FAT, graphical user interface, GUI, local area network or LAN, microprocessor, operating system, random access memory or RAM, read-only memory or ROM, single inline memory module or SIM, software, static RAM or SRAM, synchronous DRAM or SDRAM, universal asynchronous receiver transmitter or WART, UART, and finally wide area network or WAN. The personal computer or PC has evolved over many years. Computers of today are not only useful but are also decorative and even portable. Computers have evolved from machinery that took up the space of a large room to the size of our desktop, or palm-sized even, figure 25-1, or even smaller. Today's computers allow us to perform a variety of tasks in places we could never before imagine and affect nearly every aspect of our lives. Some fields, computers assist us in our education, figure 25-2. The sciences, entertainment, transportation, communication, defense, manufacturing, finance, and business are all affected by computers. Computers are used in schools and universities to educate students in various academics. Computers help scientists predict weather patterns and major geologic shifts. They help those in the entertainment industry edit and produce music and movies. They're also a major source of entertainment in nearly every home to those playing games, sending and receiving email, and exploring the internet. Computers allow for safer travel in the air and on highways. They are a must in today's world of high-speed communications. They play an important role in the country's defense system and have been accredited with contributing to great advances in the civilian world as a result. Computers make manufactured products more dependable and less expensive. They help us calculate faster and with much more ease. Computers have become a basic tool in nearly all offices and businesses today, making a more efficient workforce. Computers perform far more tasks in our world than can possibly be mentioned. This chapter will introduce you to the basic concepts of the PC based on the IBM compatible figure 25-3. Or the Intel 80XX family of processors. The Apple computer switched to the Intel processor platform in 2006. Although the Apple computer is not specifically discussed in this unit, there are many similarities in the computer system hardware. The main difference between Apple and other leading brands of computer is the operating system. To cover the PC in depth requires many hours of instruction. After completing this introductory course in electricity and electronics, you may wish to go into to study PC repair as a career or simply gain more in-depth knowledge of PC operations and capabilities. 25.1 PC repair. PC repair originally fell into the topic of electronics repair. However, computer repair has become its own profession. While a background in electronics can be a major asset to a computer technician, this study is not an absolute necessity. However, many PC technicians often return for more instruction in electronics basics. Though a PC is a complex assortment of digital electronics controlled by operating system software. On the surface, it may appear that a PC is quite easy to repair or upgrade. In fact, in many cases this can be true. However, most times PC repair or upgrades require the expertise of a highly trained PC technician. Computer problems may be complex and interrelated to other issues regarding hardware, software, networking, or connectivity. Do not be fooled by the simplistic approach of the repair to simply swap out modules. Many times the problem is not the hardware at all, but actually a software problem. The PC technician must be able to accurately diagnose the problem to complete a repair and ensure that at the same time that the problem does not reoccur. Computer problems can be broken down into three major areas: hardware, software, and users. Common points of hardware failure. Hardware does fail, but not as often as people might think. Two of the most common hardware components that fail are the hard disk and the modem. The hard disk drive is in constant use and is a combination of an electronic mechanical device. See figures 25-4 and 25-5 shown on the screen now. Many mechanical devices wear out much faster than electronic components, but not all mechanical devices cause hard disk drive failures. Many hard disk drives are attacked by a computer virus or worm program that causes the computer to appear completely dead or behave erratically. Modems often fail because of lightning strikes to telephone lines, since the modem is connected directly to the telephone system. The lightning strike often hits the modem even when the PC is turned off. Also, modems could be connected to the coax cable of your cable TV provider, and likewise suffer from a power surge. A surge protector with telephone protection should always be used. See figure 25-6. Software can also cause computer problems. Software is designed to go hand in hand with personal computers. But even if the software documentation says it is made to work with a particular operating system, compatibility issues still could arise. Users actually account for the majority of computer-related problems. Most computers have many options and settings. These can be changed accidentally or intentionally once a user accidentally creates a problem. They typically cannot reverse their own error. In fact, many users cannot even replicate the problem to show a PC technician what they've done. Many so-called viruses are actually problems created by the user accidentally changing system or software settings. To properly troubleshoot a PC, a technician must learn to be patient with users, while also understanding the electronic, mechanical, software, and hardware functions of a PC. Originally, PC technicians performed component-level repair on computers. Today, all the parts in a typical PC are considered field replacement units, or FRU. An FRU is a module that can be easily replaced rather than repaired. The entire computer can be broken down into FRUs. Some examples of FRUs are the hard drive, floppy drive, CD-ROM, DVD, memory chips, power supply, and motherboard. In a practical application, there is no one item in a modern PC system that must be replaced in a computer repair shop. However, it is not uncommon for a PC technician to have to order an FRU or to remove the computer from the site for such replacement. These issues depend on the condition of the repair environment. Such repairs may take a computer out of service while a replacement unit is found. Data recovery. It may be interesting to note that there are data recovery businesses that specialize in recovering data from a failed and damaged hard disk drive. Data recovery is not limited to software utility programs. Many times hard disk drive failures are caused by electronic components and drive motor failures. Data recovery companies can still salvage data after the drive mechanics have failed. It takes a highly skilled electronics technician to replace the electronic components associated with the hard disk drive. Once the hard disk drive controller, board, or drive motor has been replaced, data can usually be recovered. Computer technology certifications. There are many advanced technical certifications available for computer hardware and software operation and repair. One such certificate available through the CompTIA organization is called the 8 Plus certification. CompTIA is a not-for-profit organization designed to certify a technician in non-vendor specific or generic computer maintenance and repair. In other words, the CompTIA does not certify any one particular computer brand, but offers a general examination that tests candidates to ensure that they are qualified to perform common maintenance, repairs, and support on computers. Many computer manufacturers require CompTIA certification before allowing students or employees entry to specialized training on their products. Many companies, such as Nortel Networks, require their technicians to become certified not only in PC repair, but also in basic networking. This is because there is virtually no single modern piece of equipment that does not rely on some computer technology. More and more electronic equipment, such as radar systems, cable television, biomedical equipment, security systems, fire alarm systems, commercial airplanes, military weapons, and even diesel engines, rely on basic computer and networking technology. Computer certification will become a common requirement for most technician jobs in the future. Any person interested in pursuing a career in electronic computer technology should acquire a good foundation in computer hardware and software and obtain one or more computer certifications. The PC as a tool. The personal computer has become an effective tool for electronics technicians, as well as technicians in most other fields of study. Resources such as board information, electronic theory simulations, electronic calculations, schematic diagrams, and schematic drawing tools have become commonplace through the use of the CD-ROMs and internet sites. Special computer adapter cards can be inserted into a PC, allowing a computer to display oscilloscope images of live circuits or to serve as a multimeter. The PC is now a vital tool for the study of electronics as well as a resource for troubleshooting and learning new technologies. As a student of electricity and electronics, you have a head start on many of the PC concepts because of the background obtained thus far. However, there's still a lot to learn. Review questions for section 25.1. What are the two most common computer components that fail? That is the hard disk drive and the modem. Although that is quickly changing, if not already completely changed by now 2018, where we have solid state hard disk drive, which is a very reliable and hard to fail device, and modems are usually not even a problem anymore, because most of the time there is a board, a very robust board within the computer motherboard now, that is not separate from the computer itself, but it is just an Ethernet connection on the motherboard itself, which is extremely reliable, and I have yet to see one fail in the last 10 years alone. Question number 2. The hard disk drive is a electronic mechanical device, again, that has changed again with the solid state drives or SSD hard drives that are now available. Question 3. In the field of PC repair, what are the parts within a typical PC considered? And they are line replaceable units or field replaceable units, FLRs or FRUs. 25.2 Computer Design Components and Technologies. This section covers the computer's physical design and components, as well as technology relating to data storage and file formats. By becoming familiar with the computer's components and technologies, you will have laid a foundation on which to build a further knowledge, either in your studies as a nearly all computers today still use some basic type of the 4 categories of equipment designed in the mid 1940s. Computers contain equipment pieces that are designed and programmed to work as a single unit. The basic design of every computer includes an input device for entering data into the system, an output device for retrieving data from the system, a central computer or central processing unit or CPU for processing the data, and a storage device for storing programs and data. Input can be any type of data, such as numbers, words, symbols. Processing is done in a preset sequence as the computer follows a program's instructions. Programs and data are stored in memory. Keep in mind that programs are often called also apps or applications. Output can be printed material. Data can be sent to other equipment or through communication over the phone line or other means. The remainder of this chapter will contain an overview of the various computer components and functions. An in-depth study of each of the items covered is required to become a proficient PC technician. The case. There are 3 classic case styles used for PCs up to today, 2018. The desktop tower and mini tower. Figure 25-8 shows these 3 types of desktop styles. The desktop, as its name suggests, generally sits on top of the user's desk, but not all the time. The desktop's wide surface makes it an excellent platform for a monitor in some cases, and the case's minimal height, about 8 inches, for a full-size desktop, conveniently places the monitor at eye level with the user in most instances. The tower, representative of its name, is a tall, narrow unit designed to sit on the floor, beside a desk, or inside of a cabinet. However, it can be placed on top of the desktop if the user prefers. The mini tower is a modified version of a standard tower. It is slightly shorter than a typical tower model. Case styles are left to the user's taste, desk design, space limitations, and sometimes the requirements of the job. However, One of the important aspects of selecting a case is the number of bays available for mounting devices such as CD-ROM, floppy drive, DVD, and hard drive, among other means of storage. Some case styles have a limited number of bays, which could cause expansion and diversification issues with advanced use. Figure 25-9 shows some of the expansion bays. External bays provide a location for installing devices such as floppy drives, DVD players, tape drives, and other accessories that are intended to be physically accessed by the user. Internal bays provide location inside the computer for devices such as hard drives, which do not need to be physically accessed by the user. Unused external bays typically have a cover over each of the device bay areas. The cover can be easily removed, leaving the bay area exposed for installation of a device. Form factor. The case, motherboard, and power supply have what is known as a form factor. Some common form factors are the XT, AT, the Baby AT, the ATX, and the Mini ATX. The form factor defines the physical attributes of the item, such as the length, width, and height. In other words, the case, motherboard, and other power supply form factors must match to be physically compatible with each other. Input devices. Input devices allow entry data into the computer or entry of data into the computer. The device is controlled by program instructions that send a command to an input or output channel or an I/O channel. Examples of these commands may be to enter a letter pressed on the keyboard or to move the cursor across the screen. Input devices are also known as peripherals. Some examples of input devices include keyboards, an optical or wireless mouse, a roller ball or touchpad, and a game controller. Figure 25-10 lists examples of some common input types or devices. The power supply converts standard 120 volts AC electrical energy into DC voltage levels. The typical DC voltage levels are 12, 5, 3.3, -12, -5, and 0, or even ground. The power supply provides power to many devices, such as those used by the computer, such as the hard disk drive, floppy disk drive in ancient cases, and the CD-ROM. Figure 25-11 on the screen shows the power supply. It also supplies power to the motherboard. The ATX power supply connection on the motherboard is a single unit that is keyed. This means that the connection to the motherboard is designed so that the power supply's connector can fit only in one way. Earlier models, such as the AT and XT, used a pair of motherboard power connectors. Although these connectors were also keyed, technicians had to use care in connecting them to the motherboard because they could easily be switched, resulting in a damaged motherboard. A memory aid in correctly connecting the two power connectors to the motherboard is the black goes to back. This means that the black wire on each power connector should be next to the other when plugged into the motherboard. The motherboard. The motherboard is a sophisticated electronic circuit board that provides the communication pathways between all major computer components. The motherboard houses the CPU, memory, expansion slots, chipsets, BIOS, CMOS battery, oscillator circuit, and other electronic components. Figure 25-12 shows this. The small circuit paths, called traces, running in parallel across the motherboard, shown in figure 25-13, provide a path for data, control signals, and power. The power supply to the motherboard is limited to the low wattage needs of the motherboard's electronic components. Components such as hard drive or hard disk drives and CD drives, which require larger volumes of electrical energy, connect directly to the power supply. The motherboard also provides slots for expansion cards. The slots provide a quick and easy way to connect to the motherboard system or to the motherboard bus system without the use of solder. An expansion card can simply be inserted into the slot. The two main types of slots encountered are industrial standard architecture, or ISA. Again, that's industrial standard architecture, ISA, and peripheral component interface, or PCI. Now, the most common ones are for light commercial and residential use are the ePCI or PCIe, that is PCI Express. ISA is one of the oldest types of slots and was developed many years ago. It is not manufactured into boards any longer. That is for wide distribution. They are still manufactured for, again, industrial use. The PCI type of slot is standard today, more like the PCIe that has changed over the last 10 years or so. The PCIe has become a lot more prevalent than the PCI. A single accelerated graphics port, or AGP, may be encountered only for video card use. AGPs are going away, as for my experience as well, and they have been for a number of years now. Video cards are designed to offer greater enhancements than standard video circuits built into a typical motherboard. Video cards often contain their own BIOS, additional RAM, and a processing unit, such as an accelerator or a coprocessor, to support high-speed graphics and to operate with minimum CPU intervention. See figure 25-14. Computer motherboards have a variety of external connections. The exterior ports of a motherboard are shown in figure 25-15. Notice on this motherboard there are two RJ45 ports used for networking, which is an enhanced feature. The LAN 2 port is used to share internet connection with another computer. The audio input and output ports, the coaxial audio out port and the Toslink audio out port, are designed to support entertainment. The CPU, for central processing unit, or microprocessor. The microprocessor processes all the software program's instructions and is responsible for manipulating data. It also contains an arithmetic logic unit, which handles all mathematical computations. There are two main types of memory used in a computer: RAM and ROM. That is RAM and ROM. Both are classified by their ability to retain program data and instructions after power is no longer supplied to the chip. The contents of read-only memory, ROM, are retained after the power to the computer is turned off. The ROM chip located on the motherboard is called BIOS. BIOS. The BIOS contains programming that is vital to the computer's operation. It would be impossible for the computer to run without a BIOS. The BIOS will be covered in detail later in this chapter. Other types of ROM will be discussed in chapter 26, Microcontrollers. Random access memory, or RAM, is a temporary storage area that loses content when electrical power is interrupted. The contents of RAM constantly change as you load and unload different programs. When you're finished with one program and start another, for example, when you are finished with one program and start another, the new program is loaded into RAM, replacing the last program. It is also possible to load more than one program into RAM and then switch between programs. This is called multitasking. There are two main types of RAM used in computers: dynamic and static. There are others. Dynamic RAM, or DRAM, is composed of millions of transistors and capacitors. Figure 25-17. The capacitors are used to maintain a charge at the base of the transistor. The charge of the capacitor determines the transistor, if the transistor is open or closed, across the emitter and the collector. The open or closed connection, or condition, represents data stored as a binary 1 or 0. The capacitors hold electrical charges in patterns matching the binary data patterns. While large capacitors can hold an electrical charge for a long period of time, the microscopic sized IC capacitors cannot. Because the capacitors lose their charge quite rapidly, they must be constantly recharged. The constant recharging is referred to as refreshing, and how often it occurs is called the refresh rate. Typically, the RAM needs to be refreshed thousands of times per second. Static RAM, or SRAM, is composed mainly of digital flip-flops that retain their state of 1 or 0 until the power is removed from the chip. This is seen in figure 25-18. SRAM is much faster and more expensive than DRAM. SRAM is typically used when small amounts of memory are incorporated into other devices to enhance their performance. For example, the CPU has a small amount of RAM incorporated into the chip. This small amount of RAM is called cache, pronounced cash, as in money, and is composed of SRAM. Synchronous DRAM, or SDRAM, is an enhanced version of DRAM found in many computers. The S represents synchronous, not static. SDRAM runs in synchronization with the CPU, producing a higher overall memory performance than simple DRAM. Because the SDRAM data transfer is coordinated to match the CPU timing, there is no delay before transferring data to and from the main memory, as with earlier versions of memory technologies. Another form of special DRAM is the double data rate DRAM or DDR RAM or DDR DRAM. DDR DRAM is designed to transfer data at twice the normal data rate transfer speed. Until DDR DRAM, data was transferred at the same rate as one complete digital signal cycle. DDR technology transfers data on both the rising and falling edge of a digital pulse. Figure 25-19 shows that it's on top of the screen. DDR2 is the next generation of DDR memory. DDR2 operates at a lower voltage than DDR. The lower voltage counters the heat effect of the higher bandwidth produced by the module. DDR2 uses a different motherboard socket from DDR and is not compatible with motherboards designed for DDR. The DDR2 DIMM key does not align with the DDR DIMM key. If the DDR2 is forced into the DDR socket, it will damage the socket and the memory will be exposed to high voltage level. SIM, DIMM, and SO-DIMM are PC memory chips that are packaged in several different styles. The SIM, that's CIMM, a single inline memory module, is a row of DIP or DIP memory chips mounted on a circuit board that BIOS. The Computer Basic Input Output System, or BIOS, contains the programming necessary to start the computer and then hand control over to the operating system. The BIOS program performs several crucial functions. See figure 25-21, left side of the screen. First, it starts the computer when the power is supplied to the PC. The BIOS performs a power on self-test or post. The post checks to see if the major components such as memory chip, CPU, power supply, and video circuitry, keyboard, and hard disk drive are in working order. In order to perform detailed checks, but rather a basic set of tests, it does not perform a detailed check on these systems, but rather a basic set of tests to identify that the components are installed, have power, and appear to be in working order. Later, when the post is complete and the actual operating system is installed, a more detailed check is performed. The BIOS is also automatically detects any new hardware that has been added to the system since the last time the computer was started, detecting and installing the communications necessary for a new piece of hardware is referred to as plug-and-play (PNP) technology. Plug-and-play means that most hardware devices designed today can be automatically detected at startup. Install all necessary software programs and begin working immediately. For example, if you installed a sound card The system would automatically detect it and install necessary software to finish setting up the card. It should be noted that plug and play does not automatically detect and configure all hardware. Therefore, hardware still often requires human intervention for setup. The BIOS also contains the CMOS, pronounced CMOS, setup program. This program is normally accessed during boot up, allows a user to configure system settings such as date and time, drive configurations, boot order, and built-in peripherals like serial, parallel, USB, etc. The settings are not saved in the BIOS, but are stored in the CMOS. The CMOS, which stands for complementary metal oxide semiconductor, is a type of memory that can hold its data even after the computer is turned off, as long as it receives power from a lithium battery. In the earlier computer systems, CMOS was located in the real-time clock, or RTC chip. Today, CMOS is located in the chipset. The original BIOS chip was a true ROM, meaning that a program could only be written once on the chip. The ROM could not be erased or rewritten to. Today's more modern BIOS is actually referred to as flash memory because the new program can be flashed into or written in the BIOS chip. The chipset. A chipset is an integrated circuit on the motherboard containing control circuitry that interfaces to the computer's subsystems such as memory, CPU, and input and output devices. Figure 25-22 shows this. Chipsets are designed to carry out instructions that do not require CPU intervention. The earlier computers processed all instructions and all data directly through the CPU. As the computer evolved, it became apparent that many redundant processes did not require continuous intervention from the CPU. For example, when a program loads or transfers data from a floppy disk to a hard drive, it needs to go directly to RAM, where it will be executed. Since each bit of data or program does not need to be processed by the CPU, direct memory access, or DMA, was developed so that data could go directly to the RAM from the storage media such as a floppy disk or hard drive. Today, chipsets are inserted into the key points along the motherboard bus, support the direct movements along the direct movement of data from the floppy or hard drive to the RAM. For this, see figure 25-23. A similar technology known as bus mastering was developed to move data between any two major components in a computer, such as a modem to the hard drive, a floppy drive to a modem, or a network card to the hard drive. Typically, bus mastering moves data from ports to a device, such as a serial port to a hard drive. Bus mastering also relies on a special set of chips built into the motherboard that permit data to move between two devices without going directly through the CPU. Mass storage devices. Two main technologies used to store massive amounts of data are magnetic storage devices and optical or laser devices. The hard disk drive, floppy drive, zip drive, and tape drive uses magnetic principles for storing data. The CD-ROM, CD-RW, and DVD use laser lights technology to store and retrieve data. Two of the most common magnetic storage devices associated with computers are the floppy disk drives and hard disk drives. Each utilizes data storage based on magnetic principles with which you are already familiar. As you know from earlier studies, electricity can produce magnetism and magnetism can produce electricity. Using these principles, magnetic patterns representing digital patterns of ones and zeros can be stored and retrieved from special disks. Figure 25-24. The disks are coated with an iron oxide material that is easily magnetized. A hard disk drive is very simple in construction. It contains one or more platters that are coated with a special iron oxide. The iron oxide retains magnetism induced by the read-write head attached to the end of the actuator arm. The magnetic patterns are in response to digital pulses sent to the read-write head from the computer motherboard and CPU. The digital pulses represent computer data. Converting the digital pulses into magnetic patterns on the disk surface is called writing data to the disk. The operation can be reversed to retrieve data from the disk. The fast-moving magnetic patterns on the disk cause magnetic lines of force to cut across the read-write head, producing digital pulses representing the stored data on the disk. The process of retrieving data from the disk platter is called reading. The file allocation table, or FAT, is used by the operating system to keep track of files on a disk. The FAT includes information such as the name, date, and time of the creation or modification of a file, the file's location, and the number of sectors used by the file. The file allocation table also records the location of every area on the disk that is used for storage. Storage areas are referred to as sectors. The FAT is the oldest and longest used file system for personal computers. The original FAT16 file system was developed for the early disk operating system DOS, although DOS has been virtually replaced by the Windows operating system. The FAT16 system can still be used by these systems. The two common FAT systems are FAT16 and FAT32. FAT16 is so named because it uses a maximum of 16 bits to identify each sector on a disk. FAT32 uses a maximum of 32 bits for sector identification. The new technology, file system, or NTFS, was developed for the Windows NT operating system and newer versions like Vista and Windows 8, Windows 7, 8, and now 10. The file system is structured similarly to the FAT16 and FAT32, but it is greatly enhanced to provide better security in large disk access. CD drives. The CD-ROM read-only, CDR recordable, and CDRW read and writes, and DVD technology are all very similar. All of these technologies use laser diodes to read the disks. See figure 25-25. CDR and CDRW drives can also write to a disk and store data on the disks as a series of lands and pits. A land is the reference to the disk's surface, and the pits are the actual pits in the CD-ROM disk. The lands and pits symbolize the ones and zeros, highs and lows that represent the data. CDR and CDRW technologies are similar except that the land and pit areas are simulated through the use of a photosensitive material inside of the disk. The photosensitive material can be made to resemble the land and pit areas used in the traditional disk system by applying higher than normal laser light to the organic material. When the higher than normal laser light strikes the organic material will no longer reflect light. By no longer reflecting light, it represents data. The same way the pit areas do on the DVD. The DVD players use laser optic technology to play back the data stored on the disk. Rather than using the conventional infrared laser diode as a sort of source of light, the DVD system uses a new laser diode that produces light in the blue spectrum. This means the light has a shorter wavelength. This makes the system capable of reading a smaller pattern of pits on the disk. Figure 25-26 shows the difference between a CD and a DVD system. This allows more data to be stored on a disk. The double-sided dual-layer disk can store up to 17 gigabytes of data, or 8.5 gigabytes on each side of the disk. That is seen in 25-27. The digital video disc is a high capacity storage medium, again that's the DVD, which is used to store full-length movies, computer programs, and other information. While the typical compact disc can store 650 megabytes of information, the DVD can store up to 17 gigabytes. This is over 25 times the storage capacity of the same disk size. In addition of the storage capacity, DVD uses the MPEG format for compressing the video data. The combination of the greater storage capacity and the MPEG compression allows for several hours of video play. The demand generated by high-definition television and movie industries for better video recording media has led to the HD DVD and the Blu-ray disc formats. As many of you may know, the HD DVD has died out and largely falling out of the market. The Blu-ray disc is a new, not so much anymore, high definition video and data format developed jointly by consumer electronics and PC groups called the Blu-ray Disc Association. As far as my knowledge goes, it is a creation mostly led by the Sony Corporation. Both HD, DVD, and Blu-ray disc are also used as data storage media for computers. Again, the HD DVD having fallen out of the market long ago. Sony released the first laptop computer with a Blu-ray disc device in 2006. The HD DVD approach is to preserve a much previous DVD design technology to ensure downward compatibility while increasing the storage capacity. The Blu-ray disc approach focuses more on achieving the greatest possible storage capacity while not necessarily ensuring downward compatibility with previous CD and DVD designs. The standard DVD capacity is far less than what it required to record movies and television programs in high definition format. As a result, the HD DVD was developed for recording capacity of 15 gigabytes of single layer media. The capacity of a single layer Blu-ray disc is 25 gigabytes. The storage capacity doubles for dual layer disc format. The feature storage capacity are expected to exceed 100 gigabytes as the technology is refined. Note that the term disk is spelled differently. When talking about a CD or DVD technology, the correct spelling is disk. When talking about magnetic storage, the correct spelling is disk with a K. A typical CD-ROM encodes data in a spiraling path from the center of the disk to its outer edge. Figure 25-28 shows this. And this is a holdover from the old long play discs or vinyl records, which were about 12 inches wide. Like magnetic storage devices, CD devices also use a special file format similar in design to the original FAT or FAT. The CD-ROM file system, or CDFS, was originally introduced with Windows 95. Some other CD file formats are High Sierra format, the ISO 9660, and the Universal Disk Format, or UDF. The Optical Storage Technology Association, or OSTA, formed by a group of manufacturers, created a file system structure called UDF that could be used for CD-RW, magneto-optical MO disk, and DVD technologies. The UDF is the successor of the ISO 9660 file structure. One of the greatest improvements in UDF is that it allows for a bootable disk. There are many compatibility issues today due to the many different CD file formats that are not downward compatible. For example, many CD-RW files cannot be accessed or read from older CD-ROM drive systems because of the way the file is structured or organized, and the intensity of the laser used. Additionally, there are file systems designed specially for music and video, which only add to the compatibility problems between different CD drives. The modem. The modem is used to support communications across telephone lines. Telephone lines were originally designed to transmit analog signals for voice, not digital communications. Since high-frequency digital signals will not pass through a typical telephone line leaving a home, digital data and commands must be first converted by the modem from digital format to analog. In fact, the term modem is a contraction of two electronic terms that describe the general function of the modem: modulate and demodulate. A modulated signal is generated and encoded with data. The modulated signal is an analog signal, not a digital signal. When the modulated signal reaches its final destination, such as a modem on a distant computer, the modulated signal is then demodulated. That is, the encoded data in the analog signal is extracted and then converted back into digital codes, to figure 25-29. Long spans of telephone networks are in fact digital. To be completely accurate, the digital signal in the PC is first converted to an analog signal. The analog signal is then converted back to digital before it encounters the telephone switching gear located at the telephone company's hardware. The digital signal is transmitted across the vast distances and then converted back to an analog signal when it is near its destination. At the destination computer, the modem converts the analog encoded signal to a digital signal. The major chip responsible for how the modem works is called the Universal Asynchronous Receiver Transmitter, or WART, UART. For that, 25-30. The WART converts the parallel digital data into a series of stream of digital data, or into a series stream of digital data, and then encodes the digital signal into a modulated or analog signal. Moving on to the review questions for section 25.2. First, a type of memory designed to permanently retain its content is called a ROM, or Question 11. CD-ROMs and DVDs use laser diodes to retrieve data. The answer is laser diodes. 12. What does the UART do? That's UART, which is a part of the modem. It's the Universal Asynchronous Receiver Transmitter. That's what UART means. And it modulates and demodulates the digital data from an analog signal. And also it sends and receives analog signals with encoded digital data for internet communications. Moving on to 25.3, software. Software is a set of instructions used to run a computer. Software can be broken down into two broad classifications: operating systems and applications. An operating system provides the utilities needed to communicate and carry out general user interactions. Typical user interactions are storing and receiving files or data, BIOS software. The BIOS is a combination of software and hardware referred to as firmware. A software program is written and then installed into the BIOS chip. The BIOS is responsible for communication between the operating system and the computer system hardware. Originally, computers were designed without a BIOS. Software operating systems as well as application software were written to communicate the specific models of computers. Were written to communicate with specific models of computers. Computer systems as well as operating system software and application software were proprietary. There was little compatibility today because of the BIOS. Operating systems as well as software applications are normally compatible. Compatibility issues, but not always, arise with limitations regarding a specific processor family, such as the Intel 80XX or 80 or 80,000 or 8000 series processor family. As long as a PC is equipped with an 80,000 series or 8000 series processor or a compatible clone system, the software operating system and software application will work satisfactorily. For that, look at figure 2531 to see the relationship of various software programs and PC hardware. Refer back to this illustration as more software systems are explained. The operating system, or OS. The operating system, OS, is a type of software that determines how a user interacts with a computer. It is responsible for data or for how data is stored and retrieved. The OS also determines the type of security to be used. Today's modern operating systems use a graphical user interface, or GUI, which is a drawing that appears across the screen, allowing the user to simply pick and click on a desired function. See figure 25-32 for this. For example, when using the Windows family of operating systems, you can simply click on the floppy drive symbol icon to see the files contained on the disk, if there's a disk installed. Figure 25-33, bottom of the screen, illustrates a directory listing a GUI interface. To open a file, you can click or double click on it. A single click or double click will depend on the operating system being used and how it is configured. Some of the operating systems found today are Windows 98, Windows 2000, Windows ME, Windows XP, Windows Vista, and Windows NT. And not in the text, but now they have moved on to many others, such as Windows 7, Windows 8, and ultimately in 2018 there are many versions, including Windows 10. Various forms of Linux and Red Hat Linux and Caldera also exist. These systems are much easier to use than older systems. One of the most important characteristics of an operating system is the method it uses to store data. Stored data is typically referred to as files. Data storage involves such issues as the maximum size of the hard disk drive the operating system can access, and the maximum number of files the operating system can store, and the file formats, including security, encryption, and compression, the operating system can use. Drivers. Drivers are a special classification of software required to support communication between the computer system and a specific peripheral. A driver is required to translate commands from operating system and application software to BIOS and to specific hardware devices. There are thousands of different peripheral devices that can be added to a computer. While many operating systems contain drivers for previously released or commonly used equipment, no operating system can possibly be designed to communicate with all of the various hardware devices available. In fact, after a particular operating system is released, many new peripherals come on the market very quickly. A driver is required to support the translations to and from the peripheral. One of the classic examples of a need for a driver is when a new printer has been designed and released after a particular OS has been released. For the operating system to communicate correctly with the printer, a driver must be installed. Most peripherals come packaged with a driver. Disk, figure 25-34 shows this. Most of the time nowadays, the driver is already installed or automatically installed with the printer device, or it could be downloaded from the manufacturer's website. If the correct driver is not installed, the printer will print gibberish or may not run at all. This is rarely the case. All peripherals, such as mice, keyboards, monitors, printers, and scanners, require a driver. It is interesting to note that most computer crashes associated with the Windows family of operating systems are associated with an application software package that directly accesses the system hardware. This is a common occurrence in gaming software. Designers of games, and as well as applications that demand high system speed, such as some computer-aided animation or drawing programs, write code that communicates directly with the machine hardware. While in most instances it will work, it does cause the computer to lock up when the software memory usage clashes. A computer crash commonly occurs when two software programs try to occupy the same memory location at the same time. Microsoft started a program years ago that required software vendors to submit the program code and software for testing before Microsoft would allow the Microsoft logo to be displayed on the software package. Figure 5-35. This system was designed to assure software compatibility between Microsoft operating system and the application. Viruses. While computer viruses have become more controllable than in the early days, there are still some very destructive programs written for the sole purpose of causing problems within a network of computers or an individual computer. The problems can range from simple nuisances to complete destruction of data, files, and software. Viruses come from diskettes that are exchanged between users, more commonly from email sent over the internet. See figure 25-36. To avoid viruses, take care or care should always be taken when accepting software, data, or email from a source that is not prepackaged or unknown to you. Only download files from respectable online service providers. Even with precaution, there is no guarantee that a diskette or program will be virus-free. Always keep an up-to-date antivirus program on your computer. There will always be new viruses and worms that are created for destructive purposes. All smart computer users should be aware of them. Moving on to the review questions. Review questions for section 25.3. What are the two broad categories of software? That is the BIOS and the operating system. They also have programs or apps, applications. What is firmware? Firmware is the combination of hardware and software. What is the purpose of a driver? And that is to be able to, for peripherals to communicate with the computer operating system. It is a small, many times small piece of application or software for a piece of peripheral such as a printer, mouse, keyboard to communicate with the software of the computer. What is a common cause of system lockups? That is when applications or programs attempt to occupy the same memory slot or sector. 25.4 Computer devices. It is important to understand that computers today are capable of supporting peripherals that are used to be standalone devices. Computers can output data in many formats and accept data from many pieces of equipment. This data may be used separately or incorporated into other programs that the computer is currently working with. As the computer's capability expands, so will the number and type of peripherals available to enhance the computer's versatility. Many of these include a wide variety of printers, scanners, and cameras. A dot matrix printer derives its name from the pattern or matrix of tiny dots used to create the text and images you see. See figure 25-37. The dot matrix print head consists of a line of small metal rods called print pins. They look similar to a small nail. An electrical coil called a solenoid controls each print pin. The solenoid creates a magnetic field. When energized, the print pin is constructed with a magnet on one end. When the solenoid is energized, the magnetic end of the pin is attracted to the coil. When the solenoid is energized, the print pin moves forward, rapidly striking the ink ribbon. Each energized solenoid causes the individual print rod to strike the ribbon, leaving a dot of ink on the paper to form a letter, such as letter A. A series of electrical pulses are sent to the print head. The pulses are coded in a sequence that forms the letter A. The letter is printed as the entire print head moves horizontally across the paper. The common print head styles are 9-pin and 24-pin. The dot matrix printers are noisy and limited today for use with text applications, not for graphics. When graphics with fine detail are desired, other printers such as inkjet or laser are used. The inkjet printer. The inkjet printer uses a specially designed cartridge that moves horizontally in front of the paper, spraying fine mists of ink. See figure 25-38. The two main types of inkjet printers use either a thermoresistor or a piezo cell crystal to produce the force that fires the drop of ink through the nozzle. The thermoresistor type uses heat to expel the ink droplet, whereas the piezo cell uses vibration. Printers that use the thermoresistor technology are often referred to as bubble jets. Figure 25-39 illustrates a single nozzle disassembled into its major pieces: the nozzle, the firing chamber, and thermal resistor. The operation is simple. The ink flows into the firing chamber from the ink cartridge reservoir. When an electrical pulse from the computer enters the thermal resistor, the ink in the firing chamber is instantly heated to over 600 degrees C or centigrade. The extreme heat expands the ink in the chamber, causing it to fire through the nozzle onto the paper. As the chamber cools, a vacuum is created, which draws more ink into the firing chamber from the ink cartridge reservoir. An inkjet printer can fire its chamber many times a second. The single droplet is quite small. A typical low-cost inkjet printer can produce 720 by 720 drops per square inch. That's DPI. A high-quality inkjet printer can produce over 2 million DPIs, or 1400 times 1400 DPI. The piezo cell is a crystal that deflects or bends when energized by an electrical pulse. The piezo cell is used in place of a thermal resistor. The piezo cell flexes every time an electrical pulse is sent. When the piezo cell crystal flexes, the ink droplet is fired through the nozzle. When the electrical pulse stops, the crystal returns to its original shape. This creates a vacuum in the firing chamber and draws in more ink. A color inkjet printer uses 4 hues of ink: cyan, magenta, yellow, and black. This is a standard combination of colors, often referred to as simply as CMYK, K rather than B, is used to signify black. See figure 25-40. The laser printer. The printing process used by a laser printer is called electrophotographic process, or EP. Traditional printing is based on wet ink applied to paper using several different processes. Electrophotographic process is a combination of static electricity, light, the dry chemical compound, pressure, and heat. Static electricity is used to charge the printer drum to over 600 volts. After the drum is charged, an image is written on the drum using laser light from a laser diode. A spinning pentagon-shaped mirror is struck with the laser light to form an image on the drum. Intense light from the laser reduces the static charge on the drum wherever it strikes the drum surface. The image is formed from the various levels of static electricity charges on the drum. The static image is a representation of the image data sent to the printer from the computer. The drum rotates the static image past the toner cartridge, picking up bits of toner with the static charge. See figure 25-41. The paper leaving the paper tray picks up a charge from the transfer corona wire. This charge is stronger than that of the toner on the drum. As the paper passes under the drum, it attracts the charged toner to the paper. The paper, which now holds the toner image, passes through a diffuser. The diffuser produces a high or very high heat using a quartz lamp. The toner, which consists of plastic and tiny metallic particles, absorbs the heat from the lamp. This heat melts the plastic onto the paper's surface. The paper then exits to the output tray and reveals an image similar to the one on the computer screen, and of that sent to the laser printer. Caution: the laser printing process utilizes extremely high voltage levels. Never attempt to repair or disassemble a laser printer. Repairing a laser printer requires special training and safety precautions. The scanner. Scanners are used to copy graphics and text into the computer memory. Once a picture is captured, it can be manipulated with software. The picture can be reduced, enlarged, rotated, darkened, lightened, sharpened, or touched up in any other way. The scanner has a tremendous impact on desktop publishing. Figure 25-42 shows how a scanner works. The two main parts of a scanner are a light source and a charged coupled device, or CCD. In Chapter 23, Television and Video Display Units, you learned that the CCD was an integrated circuit containing an array of photo sensors used to capture images. The same technology used in the digital camera is also used in the scanner. A scanner has a stepping motor that pulls a light source along a track of wire cables. At each step along the scanner track, the CCD scans and receives the light beam. The amount of charge the CCD receives is in direct proportion to the intensity of light and dark. The CCD then transmits a series of digital signals that represent the light and dark contrast of that line. Figure 5-43, and transports the charges to a storage register. A storage register is like a series of flip-flops. After one line of data has been completely captured and transferred to the storage register, the data is then transferred in bytes to a section of computer memory. This process is repeated every time the scanner stops along the document being scanned. The CCD sensors in the array are very small and close together. The individual sensors can be spaced 15 millimeters from center to center or closer. As the popularity of the digital camera increases, scanners are used less for converting photographic images into digital images. Scanners are still used for converting printed text materials into digital text objects that can be imported into word processing and desktop publishing programs. The digital camera. A digital camera uses the same technology, or CCD, as the scanner. In the digital camera, the CCD captures all of the lights from the image at once. The individual packets of charge are then converted into a series of digital signals. The digital signals are transferred to a block of computer memory. Once in the computer memory, the data can be manipulated by software. The popularity of the digital camera is rapidly rising. Memory sizes, storage capabilities, and resolution improvements are being made almost daily. This technology will soon be commonplace. Update: the technology has been commonplace for years now, and even the digital cameras are going away. They're not being sold, not nearly as much as they used to, because camera technology or digital camera technology embedded in cell phones or included in cell phones and tablets are approaching the quality of digital camera devices, so they are not being sold. Most people, or many people, perhaps most, are using their cell phones as camera devices as well. The web camera, or webcam as it is commonly known, can be incorporated into a computer system for use in video and audio transmissions. Webcams are used for a multitude of purposes such as security, monitoring, multiple stations, personal use, and entertainment. Applications for this technology include the use by educational institutions for distance learning and by corporations for video conferencing. Computer CRT. You are already familiar with the operation of a CRT from Chapter 23, Television and Video Display Units. The computer CRT screens have a much higher resolution than conventional television screens. This as well has changed since television screens are more or less of a computer monitor, and some of them have even a higher resolution now than what the old computer monitors used to have, including 4K television resolution. Even 1080i or 1080p is a higher resolution than some of the older computer monitors used to have. A computer CRT uses a shadow mask with openings placed at a much closer interval than those in a television. Also, computer CRT monitors produce sharp images that are rated by dot pitch. Dot pitch is the distance, measured in millimeters, between two dots formed on the display area or screen. The lower the dot pitch number, the crisper the image. The typical dot pitch range is from 0.5 millimeters to 0.30 millimeters. Computer monitors are described in literature with acronyms such as SVGA, UVGA, and XGA. The acronyms are actually a description of the video standard or technology, and it's not necessarily the quality of the image being produced. All computers are capable of producing standard VGA resolution. This resolution has been incorporated throughout the industry for compatibility and to aid in troubleshooting. Video systems are memory intensive. Consumers demand high resolution images that exceed the standard VGA resolutions. See figure 25-44 for a table of some of the various resolutions used today. Many are not industry standard, but rather proprietary. The typical PC motherboard has all the necessary electronics incorporated to produce VGA as well as high resolutions such as SVGA. You will notice in the chart that there are several different SVGA resolutions because it is not a true industry standard. The multimedia card video adapter card. Some computers are equipped with a video adapter card rather than having the video circuitry built into the motherboard. An adapter card is specially designed to increase video performance and to handle all the multimedia for the computer system. The card fits into any available expansion slot on the motherboard and connects directly to the computer monitor. Special software drivers must be installed to provide communication between the operating system and the monitor via the video card. Some video cards are referred to as multimedia cards. They not only increase the quality of the video display, they also support a direct connection to the CD-ROM for sound and video. They are equipped with speaker connections and microphone connection. These cards are often expensive. They have their own RAM, BIOS, and processing unit so that the card works independently as independently as possible from the CPU. Review questions for section 25.4. Name 3 common types of printers, that is the inkjet, the dot matrix, and the laser. What colors do the letters CMYK represent? That is cyan, magenta, yellow, and black. What do the letters EP represent in relation to laser printers? That is electrophotographic process. Name 2 items that commonly used a CCD, that is scanners and digital cameras. What is the main difference between the television CRT and the computer CRT? That would be their resolution. And what is dot pitch? That is the space between pixel dots in a CRT. (25.5) LAN, WAN, and the Internet. Computers can be connected or networked to one another through cable or wireless technologies, enabling communications and data and resource sharing. A network can be limited to a single building or spread across the entire globe. A local area network, or LAN, is a group of computers connected together to share files and other resources such as printers. All computers and workstations in the system are usually connected to a powerful computer known as a file server. Figure 25-45. The file server provides the software and data files to which the workstations commonly need access. A network system is designed to save money and time. Databases are easily shared and files are easily accessed from a single location. Networks are common in businesses and educational settings. In addition to the network operating system software on the server, network client software is required on each workstation to complete communications between the workstations and the file server, printers, and modems on the LAN. The network operating system software also provides security. A network administrator uses special utility programs to set up user passwords and to limit access to certain resources and files. WAN. A wide area network, or WAN, is simply an expansion of the LAN. LANs are typically set up in a single building and connected by copper or fiber optic cable. A WAN network can have many stations miles apart. The WAN network depends on routers and hardware software device that determines the best route for the information to take. Figure 25-46. The router sends signals over telephone lines or via satellite to tie the computers and information together. Through the WAN, users have instant access to all programs and information contained in the network. A network administrator can also manage WAN security. The Internet. We have studied some significant electronic products that have made an impact on our society. Many of these products have greatly influenced the way we live and work. The telegraph, the radio, television, telephone, satellite, and computer are all examples of such products. The Internet, the World Wide Web, WWW, is one such technology. Most of us use it today and use it in a daily basis. And as an electronic technician, you will need to use the Internet often to find product information, specifications, research, and many other segments of your work. The Internet is quickly becoming the publication of choice for many manufacturers. These manufacturers now provide or require for download information that had been previously available only in hard copy or paper. The Internet allows material to be freely exchanged by willing participants. It allows access to museums, libraries, research facilities, electronic suppliers, people, and services throughout the US and the world. The name World Wide Web is descriptive of a web of cable and satellite technology across the globe that allows people to exchange a wide variety of information and services. Figure 25-47. Through the Internet, news, stories are available as they occur. Weather reports, satellite images, and advertising can be accessed instantly. The Internet can be used for purely entertainment purposes too. Figure 25-4. Games, movies, videos, and music are all available, among other things. The resources available through the Internet are virtually unlimited. To access the Internet, a user needs only a service provider, a modem for transmission, a web browser, a program that allows the user to navigate, view, and interact with the Internet, and some basic knowledge of how the system works. Many Internet providers provide free access time to allow the user to try the system, such as the old AOL, and now other systems may be in place. Wireless technology has made the Internet and many of its functions completely portable. Business can be conducted from nearly anywhere in the world, and transactions, messages, and many other types of communications can be accomplished from remote locations. DSL. Digital subscriber line, or DSL, is a high bandwidth internet connection that uses a regular phone line. This means any phone line installed recently will support DSL. Older phone lines may not, so they need to be replaced by your service provider using a DSL connection, or before using the DSL connection. You must also be within a specific distance to the telephone company office in order to use DSL or for it to work properly. DSL is a point-to-point connection, which means it will provide a steady bandwidth and will not fluctuate like other broadband connections. The required components for a DSL connection are shown in figure 25-49. Other equipment that may use the same DSL line as the PC include the fax machines and telephones. The use of either of these devices requires a filter to be installed as well. The filter prevents lower frequency signals to and from the fax machine or telephone from interfering or corrupting the higher frequency signals used for the PC internet connection. The cable modem. The cable modem is similar to the DSL modem. It allows existing cable television coaxial cable to be used for internet access, figure 25-50. The cable modem is installed between a coaxial cable splitter and PC. This configuration allows the cable to supply a television signal to the television while providing internet access to the PC. The coaxial cable connects to the cable modem from the splitter. More than one PC can utilize the cable internet connection if a router or gateway is installed. Some cable modems are a combination of modem and router or gateway. Review questions for section 25.5. What is a LAN? That is a local area network. What does a file server provide? That is the central point or location for file exchange over a network, for a network. And finally, what is WAN or WAN? It is the wide area network. And the difference between local area network is that it's and a WAN, wide area network, is that the LAN, local area network, is usually confined or limited to a building or local area, as the name implies. And wide area network is usually distributed through a bigger, larger geographic area, such as a campus, a city, a state, and even a nationwide. And again, these all pertain to computer networks. And the summary for the chapter. The overall design of a computer is a collection of input, output, central processing, and storage devices. A computer motherboard, case, and power supply must conform to the same form factor. The central processing unit, CPU, processes all software programming instructions and performs data manipulation tasks. Cache is a small amount of computer memory incorporated into a computer device. There are two main classifications of memory based upon their ability to retain program data and instructions after power is no longer supplied to the chip: random access memory, or RAM, and read-only memory, or ROM. There are two main classifications of RAM: static RAM, or SRAM, and dynamic RAM, DRAM. DDR RAM is twice as fast as DRAM. The BIOS contains the programming necessary to start the computer as well as perform basic diagnostics and interface software with hardware. Chipsets allow devices to communicate and exchange data without using the CPU. The file allocation table, FAT or FAT, is used to locate files stored on magnetic storage devices such as hard disk drives and floppy disk. The New Technology File System, NTFS, was an improvement over the FAT or FAT system of file storage. The CD Universal Disk Format, or UDF, file system allows for bootable CD-ROMs and is intended to be a way of universally exchange data between different CD technologies. A modem is used to convert digital signals into analog signals, thus supporting computer communications over existing telephone lines. The WART, or WA, or UART, is the main component of a modem. Inkjet printers use piezo cell as well as thermal resistors to force ink from ink cartridges. Laser printers use the electrophotographic process, or EP, for developing images. The computer CRT displays use the same principle as the television CRTs, but at much higher screen resolutions. A LAN is a collection of computers connected to a file server for sharing data and software. The Internet is a system using both hardware or hardwire and wireless technology, connecting together computers all over the world. To test your knowledge, questions for this all-encompassing and important chapter. First, what are the three major areas where a computer can fail, or for computer failure? That is the hardware and the software, and also the hard drive and modem. Question 2. What two PC hardware devices are prone to failure? And again, those would be the hard drive and the modem. Again, that has changed over the past few years with solid state drive technology for hard drives and motherboard embedded modems or Ethernet cards. What causes the majority of computer problems and failures? That is the software, the user, and at times the hardware. Question 4. Electrical components that are readily changed in the field are referred to as FRUs, or field replaceable units. Many times in electronics they are called LRUs, or line replaceable units. 5. Of what four major systems are computers comprised? That is inputs, outputs, processing, and storage. What is a form factor? It is the shape or size of a PC component, mainly speaking about or dealing with the size of the computer frame, sometimes called the cage or the computer box. What voltages or what voltage levels are provided by a typical ATX power supply? Again, ATX being a description of the form factor, and that is a plus 12 volts, plus 5 volts, or positive 3.3 volts, negative 12 volts, negative 5 volts, and 0 volts, including ground. Question 8. Name 6 devices commonly found on a system motherboard. And there are many. Some of them include the CPU, the BIOS chip, the CMOS, the chipset, the RAM, and peripheral connections, among many others. Question 9. What is the most common slot style on the motherboards today? And according to the writing, is the ATX. Question 10. What is cache? That is spelled C-A-C-H-E. Cache is the temporary memory storage unit. Question 11. What one major factor is used to compare CPU performance? And among many are the CPU speed, the on-chip cache. CPU speed is many times referred to as the CPU frequency. Instructional command set is another. And the parallel processing of instructions is another factor that determine PC performance or CPU performance. Question 12. What other factors influence CPU performance? We just mentioned a few of them. Question 13. What are two broad classifications of memory based upon the user's ability to readily change its contents? That is ROM and RAM. That is ROM is read-only memory, and RAM is, as many of you may already know, random access memory. Question 14. What are the two broad classifications of memory? That is based upon their electronic construction. That is DRAM and SDRAM. 15. Approximately how much faster is DRAM than DRAM? And that is twice as fast. Question 16. What is the name of the motherboard component that contains the post? That is the BIOS, or the BIOS chip. 17. What is the PNP technology, or plug and play technology? And it is a technology that is ready for installation without any further intervening by the user, or any driver installation required by the user. In other words, a software or application is not required to run the peripheral being installed. Question 18. What is the motherboard chipset? And it is the short-term memory within the disk. Question 19. What are the two most common magnetic storage media? And according to the text, is the hard disk and the floppy disk that has long ago changed. Now the hard disk and the cloud are the most common storage mediums. The hard disk and the cloud, meaning the internet, or meaning a remote or provider of disk space on the internet, accessible through the internet. Question 20. How does a floppy disk keep track of file locations? And that is with the file allocation table, or FAT system. And again, what is the name of the file system designed as an improvement over the FAT? And depending what your answer is, preferences, you can choose either FAT16, FAT32, or the newest, which is the newest as of the writing of this text, the NTFS, the New Technology File System. 22. What mass storage device uses laser diode technology? And that would be the CD, the DVD, and nowadays they have the VRD or Blu-ray disc. And if you want to also include the HD DVD, which is a obsolete or dead technology by now. 23. What computer device supports communication over a telephone line? That would be the modem, which also includes its central technology, or WART, W-A-R-T. And question 24. What chip is used in a modem? And that would be again the WART. 25. What is a combination hardware and software component, such as a BIOS chip referred to? And is referred to as firmware. 26. What is the name used for a software program that is required for communication between a hardware device and a computer? That would be a driver, which is a small application or program What is a common cause of computer system lockups? And that is when a software or application attempts to occupy the same sector of memory within a computer system. 28. What printer technology utilizes a piezo cell or thermoresistor? That would be the inkjet printer technology. 29. What is the technical name for the laser printer process? And that is the electrophotographic process, or EP. And finally, question 30. What component is used to capture the light from an image and convert it to a digital signal? And that is the CDD. Or correction, that would be the CCD, which is the charge coupled device, the same technology used in digital cameras to capture images. Microcontrollers, chapter 26. Objectives for the chapter are to define a microcontroller, explain the difference between a computer and a microcontroller, explain the function of a microcontroller or main microcontroller parts, identify various types of ROM, name the general types of programming languages, name some common components found on a microcontroller module. Keywords for the chapter are arithmetic logic unit, or ALU, assembler program, assembly language, editor, electrically erasable programmable read-only memory, or EPROM, erasable programmable read-only memory, EPROM again without the double E, high-level language, interpreter, library, machine code, machine language, macro, masked ROM, microcontroller, microcontroller interface, object code, opcode, operand, port, program counter, programmable read-only memory, PROM, register, source code, stack, stack pointer, watchdog timer, word size. And again, you should look for these words throughout the chapter, since the definition won't be shown on the screen, but they will be discussed, defined, and spoken about throughout. So keep attention and watch for the words, these definitions, and make sure that you do learn them and know their meaning and context. This chapter introduces you to the microcontroller. The microcontroller is a programmable integrated circuit. This means that the microcontroller can be programmed to perform a set of specific instructions. The microcontroller is therefore the merging of programming languages and digital logic components. Component or complex controls that once required thousands of even millions of the individual components are duplicated in a single chip. The information in this chapter builds a bridge of technical knowledge between the software programs and digital ICs, or integrated circuits. You will discover how computer software can be used to control integrated circuit devices to achieve the same results as control systems that require many discrete devices. The microcontroller has dramatically changed the way the control circuitry is designed. Again, the microcontroller has dramatically changed the way control circuitry is designed. 26.1 Overview of the microcontroller. The microcontroller is an integrated circuit, or IC, that can be programmed to perform a set of functions to control a collection of electronic devices. For example, being programmable is what makes the microcontroller unique. Often thought as a tiny computer on a single chip, the microcontroller is used in many applications that can be found in almost every electronic device we encounter daily. In this section, you will learn what makes the microcontroller comparable to the computer. You will also learn why the microcontroller has replaced many relays and solid-state devices in industry. Comparison and contrast of the microcontroller and the computer. You will find that many of the terms you will learn in this chapter can also be applied to computers. This is because the microcontroller and the computer have or share many common components. Shown on the screen are some: a microprocessor to process instructions, memory locations to store data and programming information, input-output facilities to move data between itself and another device, in figure 26-1 on the screen now. Although the microcontroller and the computer share many common components, there are many distinct differences between them. The major differences between the computer and the microcontroller are shown on the screen: the limitation of the microprocessor, the amount of memory available for data and program manipulation, and finally the type of storage available to permanently store a program. A microprocessor inside a computer is more powerful and more versatile than that of a microcontroller. The computer's microprocessor allows the computer to run a variety of programs and applications. A single computer can be used to perform a variety of functions such as word processing, playing a DVD, playing an interactive game over the internet, monitoring security systems, and making a CAD drawing. A microprocessor in a microcontroller has a limited instruction set that allows it to run a specific application. In other words, the microcontroller can only understand a limited number of commands, and these commands are specific to the functions of the processor is designed to handle. For example, a microcontroller may be designed specifically to monitor and control a fuel injection system of an automobile. In fact, every car manufactured today has many microcontrollers incorporated into its electrical system: anti-lock brakes, fuel control, air conditioning, heating and keyless security locks, among many others. Each microcontroller on a vehicle is designed to handle a specific function. The microcontroller, like the computer, uses RAM to store programs and data temporarily. The amount of RAM built into a microcontroller is minimal and is usually enough for its intended use. The RAM in a computer is ample enough to run a variety of memory-intensive applications. All computers and microcontrollers must have some sort of ROM that contains a permanent set of instructions so that they can communicate with other devices. The microcontroller stores its ROM. It stores in its ROM the program it needs to perform a specific job. Again, the microcontroller stores in its ROM the program it needs to perform a specific job. The computer has a ROM called the BIOS that contains basic programming functions. Basic is a actual program spelled in all caps. The computer stores the rest of its programs, operating system, and applications in other software or in other storage devices, such as a hard drive. A larger capacity for programs storage makes the computer more versatile and powerful than a microcontroller and allows it to run many different programs. Although computers are versatile and powerful, the microcontroller has its advantages. Microcontrollers are small and can fit inside other devices like an appliance or vehicle. Microcontrollers cost less to produce and they consume a lot less power. Microcontrollers are used in almost all types of electronic equipment, and from coffee pots to laser printers. They are even incorporated into computer systems. They can even be found in floppy drives, CD-ROM drives, and video cards. A microcontroller is often embedded into the electronic circuitry boards of these computer devices. A microcontroller is usually a single chip, but when incorporated into a large control system, it is referred to as again, a microcontroller is usually a single chip, but when it is incorporated into a large control system, it is referred to as an embedded controller. Figure 26-2 shows a controller a microcontroller in a refrigerator. An embedded controller often depends on other components in the system, such as additional memory, to perform its function. Microcontrollers are also used heavily in industry. They have taken the place of relays, solid-state devices, and other discrete components. The advantages of using microcontrollers in industry. There are a number of advantages to using microcontrollers in industry. Some of the major advantages of microcontrollers are that they are reusable, dependable, cost-effective, and energy efficient. They are reusable. The typical microcontroller is programmable, which means it is reusable. This is especially advantageous for prototyping, control circuitry, etc. When developing a complex control system, it is not unusual for it to fail when first applied. As a matter of fact, complex control projects may need to be rewritten and or rewired many times before it meets design specifications. The fact that the control circuit can be modified by programming rather than rewriting it is very advantageous for fast project prototype development. The microcontroller is also dependable. Integrated circuits such as the microcontroller are much more dependable than relays. Before, microcontrollers control circuitry relied on many electromechanical relays and timers to control the system. Relays depend on electromagnets to move armatures and contact parts, so they eventually wear out due to the mechanical friction. Relays are also susceptible to damage caused by dust, dirt, corrosion, rust, insects, and other contaminants that can interfere with the moving parts. Microcontrollers, on the other hand, have no moving parts. This provides a much higher rate of reliability. Relays and high-powered transistors can be incorporated for final application to motors, but the actual timing and control logic does not need to rely on the mechanical action of relays. Microcontrollers are also cost-effective. They can be produced at lower costs than their electrical predecessors or their electromechanical predecessors. Also, microcontrollers can be programmed if the designed application does not work correctly, or if the application for its use changes. Microcontrollers are also energy efficient. Because the majority of the circuitry is made from integrated circuits, ICs, the energy cost of using a microcontroller is much less than if using individual components of a relay type logic circuit. Relay logic uses numerous relays wired in series and parallel to form control circuit conditions similar in function to logic gates. A microcontroller consumes less electrical energy than conventional electromechanical devices. Disadvantages of using microcontrollers in industry. There are a few disadvantages to using microcontrollers. The two most prominent disadvantages are the need for skilled programmers and the sensitivity of the controllers to electrostatic charges. Programming complexity. Special skills are required to program the microcontrollers. This requires a higher level of training for some personnel. In addition, there are many different programming languages to choose from. This can lead to a compatibility problem when attempting to merge two dissimilar systems into one control system. Electrostatic sensitivity. Most microcontrollers are composed of complementary metal oxide semiconductors, or CMOS, integrated circuits, ICs. CMOS can be damaged easily by static charge. Static precautions must be strictly obeyed or taken when working with microcontrollers. Review questions for section 26.1. First, name three differences between a computer and a microcontroller. And the differences are the versatility, the size, energy efficiency, and the task. 2. What types of devices are controlled by a microcontroller? Among the many are fuel injection systems in vehicles, security locks in many vehicles, motors in industries all throughout the world. Moving on to 26.2, microcontroller components. The microcontroller consists of thousands of digital circuits. These digital circuits are combined into areas that provide specific functions. The simplified block diagram illustrates how the major sections inside of the microcontroller work together to process the program instructions. The parts of the microcontroller are used to save data and programs, perform math and logic functions, and generate timing signals. The different areas are connected by a bus system. The bus system contains tiny parallel circuits that carry the digital pulse patterns from section to section. The ROM stores the program required for the microcontroller to function. The ROM controls how the chip components operate and how data and instructions flow through the chip. Ports and registers. There are many different types of registers and ports found inside of the microcontroller chips. Ports and registers are special memory locations dedicated to a specific function, such as a hardware location or place to manipulate data. Some ports correspond to the input and output pin assignments of the chip. By placing a 1 or 0 into a specific port address, you can change the pin assignment of the microcontroller from an input pin to an output pin. Ports can also contain information sent to the pins on the microcontroller chip from sensors or from sensors or switches. Again, ports can also contain information sent to the pins on the microcontroller chip from sensors or switches. The contents can be then stored in memory or remain in the port. A register can be used to hold the contents of data being manipulated. For example, when performing a mathematical operation, the data being manipulated must be stored in 2 different registers and the result placed in a third register, figure 26-4. The illustration, you see 3 registers labeled as A, B, and C. The content for register A and the content of register B are added together and then stored in the register C. Another typical use of a register is to store a value to be compared to another register value. For example, compare the content of register A and the content of register B. If the values are identical, an action is initiated, such as turning on a valve, activating a door switch, or turning on an alarm. The contents of the two registers A and B could compare the temperature rise to a preset value or the distance moved by a robotic arm. As you work with programs in memory, the use and application of registers will become more apparent. Stack, pointer, program, and program counter. Stack, pointer, and program counter. The area in memory that is used to store data and program information is called the stack. The most common use of the stack is to store the program address of the next instruction to be executed. Since the processor processes commands sequentially, one after the other, until complete, it relies on the stack to temporarily store the address of the next instruction in the same main program in the case the main program is interrupted. A special device called the stack pointer keeps track of the last stack location used while the processor is busy manipulating data values, checking ports, or checking interrupts. See figure 26-5. Interrupts are, as the name implies, a way to interrupt the processor while it is processing instructions and data to perform a different task. The interrupts come in two varieties: hardware interrupts and software interrupts. An example of a hardware interrupt is when input pin number 3 receives an electrical signal from a push button and the microprocessor stops what it's doing to respond to the signal. While it is responding to the push button signal, a hardware interrupt, the contents of the program counter are pushed onto the stack. The stack pointer bookmarks the location of the last item pushed onto the stack. When the processor finishes servicing the interrupt, the computer address is popped from the stack and returned to the program counter, and the microprocessor continues processing the instructions in order. The ALU, or the Arithmetic Logic Unit, performs common mathematical and logical operations on data. The logical operations are similar to the digital devices you have studied earlier in this textbook. Some typical logic functions are similar to the AND, OR, NOT, NOR, and NAND digital gates. The oscillator. The oscillator is a complex digital device that requires a steady digital pulse for timing. All of the separate functions are controlled by one central timing system. The timing pulse provides the basis for proper sequence of all separate sections of the microcontroller chip. The source of the steady pulse rate is the oscillator circuit. The watchdog timer. A specialized program, often found as parts of the microcontroller, is called a watchdog timer. The watchdog timer is designed to prevent a microcontroller from halting or locking up because of a user-written program. Remember that a processor processes instructions step by step. It will wait until one instruction is completed before processing the next. A problem can arise if a command is issued to a processor that cannot be accomplished. For example, a program is written by a user and contains an instruction calling for checking the input value of I/O pin 36. If there is no I/O pin 36, the microcontroller will wait forever for input. It will not process the next command until it receives input from pin 36. Without the watchdog timer, the microcontroller would halt and thus fail to process further instructions. The watchdog timer uses a routine that is based on timing. If a program has not repeated a loop, if a program has not been completed or repeated as a loop within a certain amount of time, the watchdog timer issues a reset command. A system reset sets all of the register values to 0. The reset feature allows the controller to recover from the crash. It releases the program and sets the controller to start over again. Memory. As stated earlier in this chapter, microcontrollers and computers use various types of memory. These types of memory are usually referred to by their acronyms. The two broad classifications of memory are random access memory, or RAM, and read-only memory, or ROM. These two types of memory are classified according to their function as memory units. You have already learned about RAM in detail in Chapter 25, Introduction to the Personal Computer. PC, random access memory, is used in the microcontroller just as it is in the computer to temporarily store programs and data. It is volatile memory, which means it loses its contents when electric power is no longer applied to the memory chip. Power can be lost due to power failures or by simply turning off the power switch. Read-only memory, ROM, is used permanently to permanently store a program or data and retain the information even when the power is disconnected from the unit. It is described as a non-volatile memory. In Chapter 25, you learned about ROM only as it is applied to the computer BIOS. In this chapter, we will take a closer look at many types of ROM. Programmable memory. ROM is classified as to how it is constructed and how the program code inside of the chip can be altered. Masked ROM, usually referred to as just ROM, is a special type of memory that is permanently programmed during the manufacturing process. Masked ROM memory cannot be reprogrammed. To change the program in a system using masked ROM, you must use an entirely different masked ROM chip. Programmable read-only memory, or PROM, is memory that is programmed after it's manufactured. It is manufactured with thousands of empty memory cells. A program writer burns a pattern into the empty cells, forming a program in the blank PROM chip. Like masked ROM, a PROM chip program is permanent for life, or for the life of the chip. Erasable programmable read-only memory, or EPROM, is a special type of PROM that can be reprogrammed many times. When manufactured, a small window is left on the chip. Any program entered into the chip can be erased at a later time by shining an ultraviolet light through the window on the chip. The chip can then be reprogrammed using a programming device. Electrically erasable programmable read-only memory, or EEPROM, is a type of memory chip that can be erased electrically and then reprogrammed. It is commonly used for the computer BIOS chip. A microcontroller is usually constructed with a PROM on the chip itself, containing the basic set of instructions for running the microcontroller and its internal parts. This program is permanent and not alterable. In addition to the basic ROM, another section of memory is used to store programs written by the user. It typically contains a small EEPROM memory area. If larger program storage is required, additional EEPROM chips can be connected to the microcontroller. Moving on to the special function, to the review questions for section 26.2 again. The special function areas of a microcontroller chip are connected using 26.3 Programming Languages and Terminology. A variety of languages are used to program controllers and computers. These languages range from the most basic level of machine language to a wide selection of high-level languages. Some languages used to program microcontrollers are C, C++, Basic, Visual Basic, Quick Basic, and numerous proprietary languages such as P-Basic for the Parallax microcontroller. Software programs specially written for programming microcontrollers are usually referred to as editors. Look at the illustration in figure 26-6. Use this drawing as a reference while we discuss the various languages used to program microcontrollers. Machine language, assembly language, and high-level languages. One language that can be used to program a microcontroller is machine language. Machine language, or machine code, is a computer language constructed of ones and zeros that represent binary codes and digital value or digital pulse levels. The computer understands machine code without further conversion. There is no form of code that is closer to the machine itself, hence the name machine code. Machine code is also referred to as object code or executable code. Machine code matches the type of processor with which it is communicating. For example, an Intel processor cannot use a machine code written for a Motorola or Apple processor, or vice versa. Machine code is difficult to learn and inefficient for writing programs. The main advantage of using machine language programs is that they run more quickly than other types of programming. Machine language programming was the original way to program a microprocessor. Programming in this language was very tedious, and it took many hours to write even the simplest program. Soon a faster programming language was invented called an assembly. The assembly language uses a series of words called mnemonics combined with hexadecimal data values to create a program. After the program is written, it is assembled. The assembler program converts the series of instructions into a machine code that can be read by the processor. Programs written in assembly language are very compact, efficient, and fast. However, simple programs still can take hours to write using assembly language. Most programmers write programs using high-level languages such as C, C++, Basic, Visual Basic, and Quick Basic because it is much easier and faster. Very large programs that would be almost impossible to write in assembly language can be written using a high-level language. The high-level language can then be assembled into machine language using code, or it can be assembled into machine language code by using a program code called a compiler. The main differences between using a high-level language and using assembly language is the amount of code stored after being converted into machine language and the speed of its execution. Assembly code is difficult and time-consuming to program in, but the code uses less memory and executes faster than high-level code. The assembly code is much more exacting than high-level programming languages. For example, when using an assembly, you must indicate the exact memory location to which to place the data, and each command must be in sequence followed by the proper amount of data bits. This is more work for the programmer. A high-level language is not as restrictive, however. The programmer must simply indicate the data needs to be stored in a file. However, when high-level language is compiled into a low-level machine language, allowances must be made for the fact that no specific memory location was specified. The program must use an additional set of commands to locate a free block of memory that does not conflict with another data block. Higher level languages are also not as restrictive about putting commands in exact sequence for execution. Assembly code must be in exact sequence or it will lock up or crash the system when implemented. Programming terminology. One of the most difficult aspects of programming is learning all of the new terminology. Many new words have been created, and many common words such as bit, word, and library have been given new meanings. Knowledge of these terms will help you understand the manuals that come with microcontrollers. The size of a normal group of bits processed at one time through a computer system is referred to as its word size. The word size typically matches the bus width of the chip. Some common word sizes are 8, 12, 14, 16, 24, 32, and 64 bits in length. A word usually contains an instruction and some data to be acted on. The opcode is the part of a word that contains the instruction to be carried out. Instructions are typically followed by data referred to as the operand. This is a repeating sequential pattern used in programming. Together, the opcode and the operand combined to form the source code. Source code is simply another name for the program written by the programmer. The source code is then converted into machine code by an assembler or a compiler. When source code is assembled or compiled, it becomes what is known as object code and is saved as a file. Object code is also called executable code or machine code. Source code can also be run directly by an interpreter. The interpreter runs the source code without compiling the code into machine code, figure 26-7. Many times, programmers will save the programs they have written so that they can use the code again on another control system. As you work with programmable devices, you will notice how much of the code can be reused for another project. A library is a collection of code modules. For example, the robot project that is covered later in this chapter can be programmed to perform in a number of ways. It can be programmed to run while connected to a PC. The keyboard arrow keys can be used to control the robot's movement. The robot can also be programmed to follow a line drawn on a piece of cardboard without being connected to a PC. In addition, the robot can be programmed to use infrared sensors to detect objects in front of it, such as a wall. When the object is detected, the robot makes a 90-degree right turn. In every case, you can reuse some of your code blocks rather than rewriting the complete program from scratch. The parts that are reusable can be saved to a code library. Libraries are sometimes referred to as code modules. Some software systems allow you to call the code modules out of a storage memory from the main program. A macro is a collection of assembler instructions represented by a single word. A macro assembler converts macros into machine language. The term macro and mnemonic are often used interchangeably when talking about programming. Mnemonics discussed earlier in the assembly language are instructions that can be converted directly into machine language. The mnemonic itself looks like a short abbreviation of the actual command being issued. For example, MOV might be used to represent the instructions for move data. Review questions. 26.3. The most basic language, which is composed of ones and zeros, is called machine language. The three high-level languages are C, C++, and BASIC. Which portion of the source code contains the data? The opcode or the operand, and that would be the operand. 26.4. The microcontroller module. The microcontroller can consist of a single chip, or it can be composed of several components collected together on a circuit board to function as a single unit. When a microcontroller is mounted on a circuit board with other components, it is sometimes referred to as a module or a microcontroller board. A microcontroller module typically consists of a microcontroller, a power source, an interface for connecting to a programming device or I/O ports, and additional memory. A power source is required to power the microcontroller and any accompanying components located on the printed circuit board. An interface is needed to communicate with the controller. The microcontroller interface is usually an older serial connection or an universal serial bus USB connection matching the ones found on most PCs. A set of input outputs or I/O ports is used to send and receive signals from the devices the microcontroller is designed to control. The microcontroller's I/O pins can be programmed as output or input pins. When programmed as an output pin, each pin can output digital signals. When programmed as an input pin, each pin can receive digital signals. Devices commonly controlled through the I/O ports are relays, power transistors, servos, stepper motors, LEDs, and solenoids. Devices that commonly send electrical signals to the I/O ports are photocells, piezo cells, thermistors, and thermocouples. LEDs are often used to indicate the presence of power or that communication is taking place. Figure 26-8, top of the screen. Depending on the microcontroller's intended use, you might find timing oscillators. The oscillator circuit can be a separate component, or incorporated into the microcontroller chip. When constructed separately from the chip, a crystal or ceramic resonator is used, as well as capacitors and resistors. Figure 26-9. The advantage of using a separate oscillator circuit is that it can produce a number of frequencies rather than a fixed frequency. By having the ability to produce a wide range of frequencies, a microcontroller can match the frequency required of a large control circuit in which it may be embedded. Additional components, such as digital to analog and analog to digital converters, can be used to change the digital pulses into analog signals. If you need to drive a device requiring a higher output current, you can simply incorporate a small mechanical or solid-state relay between the output pin and the load device. A microcontroller chip usually contains a relatively small amount of programmable memory. If a microcontroller is going to be used to run a large complicated program, or if much data is to be stored, additional RAM and ROM can be mounted next to the microcontroller. A reset button can be added to clear the processor if a program fails. Microcontroller relay circuits. Many times the device or devices to be controlled by a microcontroller far exceed the electrical power limits of the controller. A method must be used to increase the power output capabilities of the microcontroller. This can be accomplished many different ways. One common way is using mechanical or solid-state relay devices. Figure 26-10 shows an application of controlling a device when the electrical requirements far exceed the output power of the microcontroller I/O pins. Microcontroller interface. Most microcontrollers interface with an IBM compatible computer through the serial or parallel port. See figure 26-11. This figure shows the connections for a standard 9-pin serial port PC connection and the PIC 16C5X microcontroller from Microchip Technology. The 9-pin serial port connection is also called the DB9. The pins 1, 2, 3, and 4 on the microcontroller are tied directly to the pins 2, 3, 4, and 5 on the 9-pin serial connection. Note that pins 6 and 7 are connected together on the serial port of the PC. This allows the PC to automatically detect communications on the port. Also, be aware that this illustration only refers to a connection to a PIC 16C5X microcontroller. It is important to always check the technical specification sheet of the particular microcontrollers you're using. Microcontroller pins for different models have different pin functions. In addition, the parallel port as well as the USB port can be used for some microcontroller communications. Questions for section 26.4. A microcontroller that consists of several components is called a module or embedded controller or an MC board. 2. Name 4 major parts of a microcontroller module. That is the memory, the I/O ports or input-output ports, the power supply, and the interface. 3. What is one advantage of using separate oscillator circuits? You can produce a number of different frequencies. 4. Which ports found on an IBM compatible PC can be used to download a program to a microcontroller? And that is the 9-pin I/O port or DB9. 5. Do all microcontrollers use the exact same pin location to connect to a serial port? No, they vary by model. 26.5 Getting started with microcontrollers. One of the most used microcontrollers by students and hobbyists is the PIC Micro. Microcontrollers by Microchip Technology. There are a variety of educational kits that incorporate the PIC microchips. Two of the most popular kits are the Basic Stamp 1 and 2 starter kits from Parallax and the PIC Basic or PIC Basic compiler The review questions for this chapter are the following. What is one of the most popular microcontrollers used by students and hobbyists? And of course that would be the PIC Micro as per the text. And 2, the language used to program the basic stamp is the interpreter. Summary for the chapter. A microcontroller is an integrated circuit that can be programmed to perform a specific function. 2. When a microcontroller is part of a larger control assembly, it is often referred to as an embedded controller. 3. A microcontroller is perfect for prototyping because it can easily be programmed. 4. A watchdog circuit is designed to prevent a microcontroller from locking up. 5. Machine language is the lowest level programming language and the language closest to the hardware. 6. Most programmers use high-level languages to write programs for computers as well as microcontrollers. 7. Computers are used to program microcontrollers, and the program is transferred to the microcontroller using serial, parallel, or USB ports. Test your knowledge questions for the chapter. 1. Explain the difference between a microcontroller and a personal computer. And the difference is that the microcontrollers are designed to work with less memory, less power, and more limited capabilities, only for specific tasks. The computer, however, can do many tasks, consumes a lot more power, it's a lot larger, heavier, and bulkier, and unable to be used for the many applications that a microcontroller would be able to be used. 2. What is the purpose of the watchdog timer? Is to prevent program from locking up due to faulty programming. 3. What does the acronym PROM mean? That is programmable read-only memory. What does the acronym EPROM mean? That is erasable PROM, or erasable programmable read-only memory. The programming language constructed of ones and zeros that represent binary codes and digital voltage pulse levels is called machine language. Name 3 or more high-level programming languages. That would be C, C++, C++, Basic, and QBasic. Also Visual Basic would be another. 8. A compiler is used to convert a high-level language into a machine language. 9. A word is a combination of instructions and data. 10. A word size is typically equal to the bus width of the chip. 11. RAM and ROM are special memory locations dedicated to a specific function such as I/O ports. And 12. A microcontroller that consists of several components is called a module, or an MC board, or an embedded controller. Chapter 27, Career Opportunities in Electronics. Objectives are to assess your interest in electronic careers, distinguish between a goods producing and service producing business, discuss a variety of electronics careers and their educational requirements, finding a career. How do you want to earn a living after you complete your education? What vocation will you choose to assure an interesting and rewarding future? 27.2 Careers in the Electronics Industry. Discoveries and developments in science and technology are made every day. Electronics and other fields of service play a major role in daily life. Think of common devices that have been improved with more complex machines. For example, the communication powers of the telephone, television, and radio have been increased through the use of the satellites. The safety of boats and airplanes have been improved through the use of sonar and radar devices. Where else is the use of electronics apparent? Industry is electrically controlled. Robots and machines are constantly displacing production workers. Figure 27-2. In many businesses, computers are can complete complex tasks in only a few minutes. Electronics has also entered the field of medicine. Using later technology, surgeons can now perform surgery without cutting any skin. With each new device that is developed, many highly skilled technicians must be trained to maintain and service these devices. The need for people with electronics training will continue to grow into the next century. Types of electronic industries. In most industries, there are two types of electronics businesses. Those are the ones that sell products and those that sell services. Some businesses combine these businesses of sales and service. In nearly every industry today, there is some sort of job set that requires the skill of an electrician or an electronics technician. The automotive skill in a particular area. This knowledge and these skills are gained through advanced study. Figure 27-5 may be a good example of this situation. Advanced study is obtained through apprenticeship programs, such as this one, courses, community college programs, university programs, and even some high school technical programs. Some skilled workers also obtain advanced training from the military services. An apprenticeship is a period of time spent learning a trade from an experienced skilled worker. This training is done on the job for the most part, not always. This training is usually combined with special classes or self-study courses, such as the one you're listening to. Your 4 years are the usual length of time of an apprenticeship program, especially in the electrical or electronics field. Many community colleges offer courses and programs in the electronics field. Courses can be taken to learn more about a particular subject, or a program can be followed to gain a particular skill. The military services offer many specialized areas of study in the electronics field. The opportunities for learning a trade are very good in the military services. Many jobs in the electronics field are skilled positions. Some of these jobs are maintenance and construction electricians, assemblers, and quality control inspectors. Assemblers wire and solder various parts for television, stereos, computers, etc. Quality control inspectors check the finished work of the assemblers. Technicians are specially trained workers capable of doing complex technical jobs. Many technicians receive their training in 2-year programs at community colleges. Figure 27-6 may be a good example of the situation. Technicians work with electronic equipment and assist engineers. They have the training needed to service and repair complex machines and components. Engineers rely on technicians to help them conduct research, test machines and components, and design new services. Therefore, technicians must keep up to date on developments in the electronics industry. Careers for technicians include broadcast technicians, robotic technicians, and computer technicians. Professionals. Nearly all professional workers have 4-year college training. Many have more advanced degrees, such as masters and even doctorates. Professionals have excellent opportunities for advancement. One of the best known professional positions in the electronics industry is the engineer. Figure 27-7 is a good example of an engineer situation. Engineers design and monitor the building of new equipment. Their goal is to design equipment that runs smoothly and does its job. Once this goal is met, technicians are assigned to maintain the equipment. Engineers must have a solid background in math and science. This background allows them to visualize designs before putting them down on paper. Teaching is another professional position in the electronics industry. Teachers of electronics have the opportunity to challenge students interested in the electronics field. They can share their knowledge and interest in electronics with their students. The rewards of teaching are many. Entrepreneurs. Entrepreneurs own and operate their own businesses. These small businesses make up 97% of businesses in the United States. They provide 58% of the jobs in America. Entrepreneurships usually start with an idea for filling a hole in the marketplace where a new product or service is needed. Then a business plan is made. This plan outlines goals for the business, along with a timetable for meeting those goals. This plan is vital if the business is to succeed. In addition to a sound business plan, a successful entrepreneur possesses certain skills. The entrepreneur has knowledge of a certain industry, service, or product. This knowledge allows the owner to to make smart business decisions about what is being sold. For example, an appliance service technician needs knowledge of the appliance being serviced. If this is not the case, the business may fail. The successful entrepreneur also has sound management skills. These skills allow the owner to manage money, time, and even employees. Entrepreneurial skills are also very important for the successful entrepreneur. These skills allow the business owner to control the business and move it in the right direction. Entrepreneurship opportunities are vast in the electronics industry. With the growth in consumer electronics products, similar growth has occurred in servicing these products. Support of the office products industry also allows for many business opportunities. Servicing of home appliances continues to be a sound business in the electronics industry. Consulting is yet another growing business in the electronics industry. Consultants work for clients on projects. The specific job they do depends on what work is needed. The consultant is paid by the client. When the job is completed, the consultant is free to move on to a new job and client. Career information resources. An excellent reference on careers is in many industries is the Occupational Outlook Handbook. This book is published by the United States Department of Labor and Bureau of Statistics. Most public and secondary school libraries have copies of this book. The book can also be viewed online at www.bls.gov/OCO. Another reference on careers is the state's career clusters website. It can be found at www.careerclusters.org. The state's career clusters initiative provides detailed career pathway to help students choose the right course of study for their careers. School guidance counselors are another outstanding source of career information. They can help you find information on particular careers, 2- and 4-year colleges that offer programs in areas that you're interested, training programs through trade schools and the military services, etc. Guidance counselors are well informed and always ready to help when asked. Education. The educational requirements for jobs in electronics industry vary. However, a minimum of a high school education is a solid foundation on which to build. Good basic mathematics and reading skills are a must in order to succeed in the field of electronics. Some high school graduates enter industry directly and receive specialized education in the training programs offered by large companies or organizations. Many of these workers do not stop at this point, however. They continue to study and read to keep abreast of the changes and new technologies that develop in this industry. Specialized training can also come from a 2-year college offering an associate degree program in technology, trade schools, and the military services. Also, programs in electronics technology. The newest statistics from the U.S. Department of Labor predicts that 90% of all technical jobs in the year 2010, which has obviously passed about 8 years ago by now, will require only a 2-year degree or technical certificate. Again, the Department of Labor predicted that 90% of all technical jobs in the year 2010 will require only a 2-year degree or technical certificate. Careers in science and engineering require a college degree. Advanced degrees are a good method of advancing. Many state and private universities offer engineering and electronics degrees. Talk with your school counselor to learn locations and entrance requirements. Many universities have websites for students. These sites contain complete outlines of electrical engineering courses. You may be interested in seeing the requirements firsthand. The chart in figure 27-9 shows major job categories and educational requirements. Study this chart carefully. These are the questions for section 27.2. What is the difference between a goods producing businesses and a service producing businesses or business? A good producing business is a manufacturing facility, for example, a business that produce, build, construct, manufacture a good or a product, usually for sale or distribution, while a service producing business produces labor and service and basically expertise to either repair and service uh, the already built or already existing product. Two, nearly all blank workers have 4 years of college training, and that would be nearly all of the advanced or skilled or highly skilled workers, especially in the electronics or electrical field. 3, after entrepreneurs pick a product to market, what is their next step? Depending on who you ask, the next step may be to uh, perform a business plan, to do market research, to do uh, trials, to begin prototyping or building a prototype of a product, to test a product that they have already prototyped. I mean, the answers could be many depending on your situation. Your next step could vary quite broadly. Question number 4. Give 2 sources for career information. 2 sources for career information are the United States Department of Labor, and nowadays many websites are available on your favorite search engine: Bing, Google, Yahoo, MSN, you name it. Just type career opportunities in the electronics field. You'll get a ton of websites, some very reputable, that may give you very valuable information. Moving on to 27.3, job search ideas. Finding a job is a time-consuming and difficult and very sometimes frustrating and intensive task. The Occupational Outlook Handbook has excellent tips for conducting a job search. Start by talking to your parents, if you have some or any, your neighbors, if you have any trusted neighbors, teachers, if you have any teacher that may want to or be willing to give you advice or guidance. And you may also look at counselors, school officials, and even people already involved with companies or in the industry, especially that of electricity and electronics. These people may know if your job or if there are any job openings that may not have been advertised. Read the wants ads in the newspaper. That's something that's been pretty much forgotten nowadays. There are many websites dedicated for job search, like Career Builder, Glassdoor. Also, there's one that's called ZipRecruiter. There's many of them that are available. Some of them changed names over the years. Beyond is another one. The text is somewhat outdated when it comes to these methods of finding work. There are also websites that help you find freelance work or contract, short-term contract or subcontract work, like FieldNation.com and Guru.com. There are many others. Companies grouped Companies are usually grouped according to the industry in the yellow pages, which is also obsolete for the most part, the print version uh, especially. You may see companies to contact in your city, county, or state employment service office, or your what they also called the unemployment office, sometimes called. They may provide you or help you find very useful and promising job leads. Private employment agencies might also provide help. Of course, there may be some disadvantages of using those, but many of them are very reputable and may help you find even a very good job. I have used them myself over the years. However, some of these companies may charge a fee if a job is found. This is most likely charged to the employer, not necessarily the employee or the person looking for work, especially for skilled people. Do not ever, this is an advice that I'm giving you, do not ever pay to find work. That is something that the employer should completely and entirely cover any costs for employment uh, employment facilitations and accommodations should be covered by the employer always. An excellent source for job information is also uh, the internet, of course. This is the primary, the upmost and foremost source for job information today. Many manufacturers post job positions. Perhaps most manufacturers post job positions that can be accessed from websites. Many times there is no longer any paper application. Now it's almost entirely done online on the website, usually company website, or even through a hiring agency. But it's 99.9% done electronically now. Once you have secured an interview, it is important to be prepared for it. Read the following tips for a successful interview preparation. Learn about the organization. Have a specific job or jobs in mind. Review your qualifications for the job. Prepare to answer broad questions about yourself. Review your resume. Arrive before the scheduled time. Not too early, but early enough, maybe 10-15 minutes prior. And also have questions for the employer ready. That's another important part that's not in the text. Personal appearance is important in most cases. Be well groomed, dressed appropriately, and do not chew gum or smoke or chew tobacco. The interview has a few parts. You must answer each question concisely, the ones that they give you, whether it's written or spoken. Be prompt in giving responses. Seem alive, look alive, and look sharp, as well as appear or respond as sharp as you can, and with as rich a language as you can. Use good manners, of course. Speak properly and avoid using slang, and also avoid using uh, is given. Very simple, straightforward resume for someone with very little or no experience. .4 Work habits. Once you have hired or have been hired into your chosen profession, it is essential that you employ positive work habits and skills. Employers will expect you to demonstrate qualities that make up professionalism and leadership, especially early on the first few months. Exhibiting these qualities will lead to a successful and rewarding time and career in the company or organization that you join. Professionalism. Professional behavior is required for success and advancement in the workplace. A good employee will demonstrate cooperation. An employee must cooperate with supervisors, other employees, and customers. Dependability. A dependable employee is timely, completes all assignments, and sets realistic goals for completing projects. Good work ethic. Good employees put a honest effort into their work. They do not spend their time or work time having extended casual conversations with their co-workers or visiting inappropriate internet sites. Respects. In order to be respected, employees must show respect for others, the company, and themselves. Leadership. Leadership is the ability to guide or direct employees who manage or supervise others. They must have strong leadership skills. However, even employees who do not manage others benefit from developing their leadership skills. Possessing leadership skills is a requirement for career growth. The following are some leadership skills. Motivation. A leader must be able to motivate others, treating others fairly, praising others when appropriate, maintaining a positive attitude, and involving others in decisions is all help to motivate people. Goal accomplishments. A leader must be able to define goals and then see that these are accomplished. Assigning tasks according to each team member's abilities and limitations helps to complete projects more efficiently. Problem solving. A leader must be able to address problems as they occur. A leader may involve others to help solve the problems, but must see that a solution is found. Recognizing limitations. Leaders must recognize their own weaknesses and be willing to rely on others to help in those areas. Role model. A leader must serve as a role model for other employees through both words and actions. Leaders must always behave in a manner deserving of respect. The general skills listed under professionalism and leadership are as important as specific job skills. Developing these skills is essential to being successful in any career. After you have put forth your best effort, you will want to make sure that you're always treated fairly in the workplace. Every employee should be familiar with the federal laws that protect them from discrimination and harassment and ensure their equality. You can view these laws online at the U.S. Equal Employment Opportunity Commission website at www.eeoc.gov. On to the questions for section 7.4. List 4 qualities of professionalism. That is motivation, dependability, good work ethics, respectful. List some attributes of a dependable employee. And that is, again, being respectful, being motivated, being ethical, being fair, being on time, being dependable, and not abusing others or abusing the company as far as abusing their time, abusing their resources, etc. 3. What are some ways in which a leader can motivate others? By praising the person when they do good, by assigning tasks to people or persons, co-workers, employees according to their uh, limitations according to their skills, according to their knowledge. Number 4, why is it important for an employee to exhibit professionalism and leadership? This is to maintain order and respect in the workplace. This is to maintain a degree of efficiency and productivity, and also to maintain an environment where people contribute as best they can with the skills and knowledge that they bring to the table. Summary. Goods producing businesses produce tangible products. Clear enough. Service producing businesses produce useful labor that results in a need or want being filled. Semi-skilled workers perform job tasks that are often simple and repetitive. These workers do not require much high levels of training. Skilled workers have a thorough knowledge of and skill in a particular area. Apprenticeship is a period of time spent learning a trade from an experienced skilled worker. Technicians are specially trained workers capable of doing complex technical jobs. Professionals are highly trained workers. Nearly all have 4-year degrees, and many have masters and even doctorates. Entrepreneurs are people who own and operate their own businesses. 3 skills required by the successful entrepreneur are knowledge of a certain industry, service, or product, management skills, and entrepreneurial skills. Professional behavior is required for success and advancement in the workplace. And finally, leadership is the ability to guide or direct. Moving on to test your knowledge. First, list 3 new electronic devices that will require maintenance by specially trained technicians. That would be the computer systems we spoke about in this session. That would be robots in the robotics industry, and also the many automated machines, conveyors, and systems, sorting machines, machines that perform welding, machines that perform any kind of cutting, any kind of action will be most likely need the maintenance and servicing by highly trained electronics and electrical technicians. What are tangible products? Tangible products are products that are physical, occupy space, occupy a certain need in society. They provide either a service, they provide some sort of utility. Question number 3, in 2016, which is about 3 years ago now, nearly 4 out of 5 jobs will be in the industries that provide, and the answer is service. Fill in the blank. A or an blank is a period of time spent learning a trade from a skilled, experienced worker, and that is an apprenticeship. 5. What skills do successful entrepreneurs possess? As we just mentioned, they possess motivation, they possess respectful behavior, they possess resourceful mindset, attitude. They possess a hunger or a desire for advancement, for helping, for filling a need, among many other skills. Also, they possess very many, or at least a few, very developed skills in technical or other areas. Question 6. What qualities do successful employees possess? Again, respectful and fair manner, treatment, and behavior. they possess knowledge in the field that they're involved in, or at least a willingness to learn every day as they perform the job. They possess dependability and also a high level of motivation. And that concludes not only this chapter, but this concludes this entire course, this electricity and electronics course. Congratulations, you have completed this very in-depth and very involved and challenging course. Again, electricity and electronics. After you finished all the reviews, quizzes, tests for these last few chapters, and also any experiments that they may have had, you will have earned this ultimate electronics course rank of O11, or the equivalent of the Army, the General of the Army rank. Again, congratulations. You are invited to review any of the chapters, any of the sessions, any of the quizzes, reviews, tests, or experiments that we may have covered over the past many hours. And please do continue to learn, albeit not necessarily by taking any other courses, but through research experience and your original developments. Again, thank you very much. This has been a production prepared by Hector Bello in the months of January, February, March, and April 2018. These chapters have been put together in this format for educational purposes from material in the Electricity and Electronics book, 10th edition, by Gerrish and others. Again, thank you very much and good luck with any further developments and studies in the area of electronics and electricity.